Welcome to Makino's Center of Excellence in Auburn Hills, Michigan. My name is Brian Coward. I'm the EDM product line manager for Makino. And today we're going to talk about the Hyper-i wire EDM control and some select features that are on the control that may be useful. So first, we're going to talk about those select functions that we have available. We're also going to talk about the QV assist window. This is a new feature on the Hyper-i, which will prompt the operator to do certain things at certain events during machining. And we'll talk about that later. Then we're going to go out to the machine in the showroom, and Anthony is going to give us a demonstration on all of the different functions that are available for automatic wire threading. Then we'll come back in, and Anthony and myself will be available for questions. So first, let's talk about some of these select functions that we want to talk about. So first, we're going to talk about select functions on the Others page. Now, the Others page is a page on the control, and down here, if you can see in the right-hand corner, there's a little 3-button box, and you press that, and it will bring up the Others page. Now, we call it the Others page because, quite honestly, we never came up for a good name with it. But it is all these different machine controls, NC controls, and macros. So these are buttons and functions that you can use on the machine. So we're going to really focus on these NC controls because these are kind of controls that you're going to use during machining. So we're going to talk about 3 and highlight those right now. We're going to talk about power failure recovery, interference evasion, and skip machining. So these are 3 features that can be very, very useful when you're machining. So first, let's talk about power failure recovery. So what is this exactly? Well, in the event of a power failure during automatic operation, once the incoming power to the machine is restored, the machine will be automatically turned on, and the machine will then resume machining at the point in the program where power was lost. So essentially, what it's going to do, if you have a power drop, the machine goes off, it's just going to sit there. When the power comes back on, it will automatically start machining again at the point. Now, for this to work, the function needs to be turned on, obviously, prior to the power failure. So you can see here on the Others page, right here, power failure recovery. So if it is white like that, it's not on. If anything's blue, that means that function is on. So you would have to turn that on prior to machining. In addition to that, you also need recovery wire brake on. So that's right there above it. Normally, recovery wire brake is going to be on at all times, so that shouldn't be a problem. So very useful function, especially if you're in an area where you have power drops quite often. Next, let's talk about interference evasion. What does that mean? Well, this function will actually recalculate the programmed internal radius when the internal radius is smaller than the machining offset. So what does that mean? So I get this question a lot. And I try to equate it to milling, right? So if I'm going to mill a pocket and I've got a 1-inch end mill, the smallest internal radius I'm going to get is going to be a 1/2 inch, right? I can't do anything smaller than that because that's the physical size of the tool I'm using. It's the same thing for wire EDM. So the wire is 10 thou that we use most of the time. That means the radius at bare minimum is going to be 5 thou. However, in EDM, you got to remember you have a spark gap because the power is going through the wire, so that the actual diameter of that cutting tool is larger than the actual diameter of the wire. So for example, if I have a program where the internal radius is 4 thou and I'm using a 10 thou wire, the offset value for that particular machining, if it's a 1-cut machining, the roughing offset is going to be 6 thou, 8.5 tenths. So obviously that's larger than 4 thou, and that's going to cause an overcut in the corner where you're going to get a little butterfly. And you can see on the button itself, it actually shows you that. That's exactly what would happen in the corner. You're going to get a little butterfly, and you're going to blow out the corner. So in order for that to not happen, you can simply turn on this interference evasion button, blue like it is right now, and the machine will automatically calculate that, and it'll put the minimum size radius that the machine could possibly create based on the offset of the wire. So it's a very useful tool. This is a very common thing, especially if the operator isn't the one doing the programming. You'll get a program, instead of having to go back to the program and redo it to do offset geometry or something like that, you can simply press this button. So many people just leave this button on at all times. That way they can avoid this problem. Next, let's talk about skipped machining. So what does skipped machining mean? So what this is for primarily is if I'm working on a part where I've got multiple features. So for example, let's talk about a mold insert. So I may have a mold insert that has an insert pocket, core pin holes, ejector pin holes. So I may have many features inside one piece, one block, that I'm going to wire EDM. So if I'm doing that, using skip machining might be a good idea, and this is why. Because what skip machining does is, when the number of wire breaks or automatic wire threading attempts has reached the maximum limit, the program will stop machining that feature, and it will move and skip to the next machining feature in the program and continue machining. So what does that mean? So let's think about it for a minute. So let's say I have that mold insert. I've got an insert pocket, some core pin holes I got to do. There's 5 features I need to machine. I do the first hole, no problem. Comes to the second hole, for whatever reason, I can't thread through that hole. Maybe the start hole is in the wrong location. Maybe the start hole is full of chips from a prior operation in the shop. Somebody didn't clean up the chips from the mill, or there's grinding grit in there or something, whatever. It misses the thread. Now it'll go on to the next feature and continue machining. In order to do that, I need to program it. So what I need to do is I'm going to need to program an M74 L number command added to the program for every machining feature that I want to record. So for example, if I have feature 1, I would call it M74 L1. Feature 2, I would call it M74 L2, and so on. So I'd mark all these locations. And what the machine is doing, it's recording those locations and remembering if the machining was complete or not, okay? If any of the features are not completed during the program, a warning message will appear and let the operator know that a feature was skipped. So essentially it's just a little warning that comes up and it'll say skip machining, and what it's telling you is that something was not completed. So since I was using this feature, now I can come into the others page again and simply press the skip machining button right here. So it's going to be white normally, but if I have a skip machining, I'm going to press it, it's going to turn blue. What that's going to do is it's going to allow me to go back and automatically machine only the features that were skipped. So the machine remembers what was already completed, it knows what's not completed. By pressing this button, it's only going to go back and machine the things that were not completed. So very useful tool if you're using machining a part with multiple features in it. All right, so that's it for the others page, but now we have some other features that I'd like to point out. And the first one I'd like to talk about is the machining timer. So the machining timer is a function that allows the operator to delay the start of machining, okay? So you set this on the finalize window, which is on the run page. So we would go to the run page here, you can see it's outlined in red, and we press finalize. Once we do that, this window is going to come up. You can see it says machining timer right here, okay? So now what I can do is I highlight the machining timer. I can set the date and the time. So what I'm telling the machine is when I want the machine to actually start the program and start cutting. So what I would do once I set it all up, now I'm going to go and select the program that I want to run, and then I'll press the start button on the handbox. Once I do that, the machining timer is now started. So now it's sitting there counting down to the date and time that I've set before it's going to start machining. So once it reaches that date and time, it's going to start machining then at whatever that specified time is. Why would I want to do this? I get this question a lot. Why would I want to do this? Well, what it does is it allows you to minimize the time that your workpiece is submerged. So for example, if I'm working on a part, I'm setting it up on let's say a Saturday morning. Come in Saturday morning, or even Friday. Let's just say Friday. Hopefully you work somewhere you don't got to work on Saturday. So you come in on Friday and you're working. Friday afternoon you're going to set something up, but it's like 2 o'clock in the afternoon. You don't want that part just sitting in the water all weekend long. So I can get it all set up, ready to go, put in my timer. Let's say the part's going to take 10 hours to machine total. So I can set that up, set the timer to start 10 hours before I'm going to get there on Monday morning. So I can set it up to start machining on Sunday night, put in the date and the time, hit that button on Friday, and the machine's just going to sit there and count down until Sunday night, and then it's going to start the program. Then I can come in on Monday morning, the part's done, it's ready for me to work on it and complete it. That way the part's not sitting in the water all weekend long. So very useful for that. A lot of mold makers use this because they don't want the part sitting in the water all weekend long. Okay, so now let's talk about the QV Assist window. This is a new feature that is on the latest version of the Hyper-i. And what is the QV Assist window? Well, it's a quick view dynamic content assistant. So right here on the right-hand side of the screen, circled in red, that is the QV Assist window. It's always going to show relevant information and functions. Based on the current machining status, it will display the items that are most relevant at that time. So what does this do for me? Well, it makes it easy to find the information and the functions that you need. So there's no need to go to all the pages, right? You'd have to go to the page, the screen, the page, the dialogue, sub-dialogue to find some of these control functions. The QV Assist will automatically bring these functions up for us based on current machine status. This is also very useful to assist new operators who maybe aren't familiar with the control in running the machine, because these functions will come up based on the machine event that is going on at the current time. So what does that mean exactly? So let's talk about a couple events where QV Assist is going to be very useful. So first let's talk about programming start, right? So right now during the programming start of QV Assist, on the right-hand side here, that's the window that's going to come up, all right? Not a lot of buttons here, but there are a few, and the most common one that we're going to use is approach. What is approach? Well, approach is going to stabilize the machining at the lead end at a specified distance. This function is primarily used for sealed nozzles technology, and that's because it's a more aggressive technology than both the way, but it can be used for any technology, right? Anytime that you might think you'll have a problem leading in with wire breaks or things like that, you can use the approach until you get into the part and you're good to go, okay? So you can't set the distance here, but where we can set the distance and specify it is on the finalize window on the run page. So the same place where we did the machining timer, same thing. We're on the run page, we go to finalize, and then underneath the approach button, there's actually a mount that you can put in there. This says 35 thou, that's way too short. So typically I'm going to put in about 200 thou approach distance. And the reason I'm going to put in 200 thou is when I get 200 thou into the part, my heads are fully sealed off, which means now I can ramp the power back up without worrying about breaking a wire. One thing to note is that that distance starts from the first spark. So a lot of people think it starts from the start position. So if you have a hole and you're coming out of the hole, you're cutting air for a while, right? That's not where the distance starts. The distance starts from the first spark condition, and the machine knows that. It senses when that spark is, that's when it goes into the approach. Next, let's talk about the QV Assist during a program stop. So if I have a program stop, this could be any kind of stop, right? This could be, I programmed an MO1, stopped at the end. It's not an M30 yet, but it's just stopped. I stopped it manually, whatever, right? This is the window that's going to come up. So you can see on the right-hand side, these are the features that are going to come up. So again, it's changing the functions that are going to be there based on what's going on at the time. So it is really a nice assistant to the operator. So a couple of the most common ones that we would use during the stop is going to be cutoff, first of all. So what does the cutoff button mean? Well, what that's going to do is it's going to stabilize machining during the cutoff. So it's very similar to the approach. The approach does the same thing. It's going to use a lower power setting till we get into a specified distance. The approach is going to do the same, or the cutoff is going to do the same thing. If I press the cutoff button, it's going to use a lower power setting. Why do I want to do that? Well, to prevent wire breaks when I'm cutting off the slug or the workpiece, because sometimes if I'm cutting off that slug, it could cause a wire break right when I cut the part off, okay? So again, primarily used for sealed off nozzles because it's a more aggressive setting, but not always. You could use it for any setting, right? Doesn't matter. Another function here during the stop that we use quite often is the lower flush. This function allows the operator to adjust the lower flushing pressure using the aux2 button on the handbox. So this is used to eject slugs up and out of the workpiece. So we come to the stop, we do our cutoff, and then we manually stop it. So remember me telling you that this window will come up, whether it's at an MOO or an MO1, or if I manually stop it. As I'm doing the cutoff, I manually stop it. This window will come back up after I've stopped machining. Now that the slug is cut off, I simply can hit this lower flush button. I can adjust the pressure with this slider, and then I hit the aux2 button on the handbox, and it'll shoot that slug out. This is very, very useful when I'm cutting materials that are not magnetic. So normally if I'm going to drop a slug, I'm going to put some rare earth magnets or strong magnets on there to hold the slug. But if I'm cutting carbide, something like that that's not magnetic, this is very useful. I cut it off, raise the head up a little bit, hit lower flush, eject that slug out, and I'm ready to keep on machining after that. Okay, so lastly, automatic wire threading settings, or AWT settings. So I'm not going to sit here and bore you anymore talking about things. Let's go out to the machine, and Anthony's going to give us a demonstration of different wire threading settings that we can use based on different applications.
Thanks, Brian. Hi, I'm Anthony. Today we're going to show you the functions on the AWT page on the Hyper-i control. Go over some of those functions. So first, I'm going to head over to the control, navigate to the maintenance page, go to AWT. First function I would like to talk about is the high-speed AWT. So there's two main buttons on our threading page that control the threading cycle. One is high-speed AWT and one is high-accuracy AWT. So high-speed AWT is just going to thread the wire as fast as possible, right? So personally, I like to use this when I'm in front of the machine, right? I'm working on the machine just because I'm impatient, you know? I don't want to wait another 30 seconds when the machine is threading, right? Now, downside to this threading function is it's less reliable, right? So it's just going to send the wire as fast as it can. If there's any hiccups or it hits a part, you might fail the thread. So I currently have high-speed AWT on. Now I'm going to hit the thread button. Now, with this threading cycle, it does not anneal the wire, and it just sends the wire as fast as it can go. And bam, we're done threading. So again, I like to turn this on when I'm physically in front of the machine, but when I'm running parts maybe unattended, I'm not, keeping an eye on the machine, maybe I'll turn this function off. Next is our high accuracy AWT function. So unlike high speed, this is going to thread the wire slower. It's going to be more reliable. It also anneals the wire and pecks. If you're, not over the hole perfectly, it'll peck the wire. And if you miss the hole, it'll also regenerate the tip, right? So if I ever get a bent tip while I'm pecking, it will come back up over a certain period of time, cut that tip off, and then kick it in this box right here. So I'm going to show you guys what it looks like to thread with this function on. So a little bit slower, you're going to see the transfer jet move up, and then that section of wire anneal, heat up. That's to keep the wire nice and straight, right? No curl, right? Maybe you're at the end of your spool and you get a small amount of curl in the wire. That kicks out the curl. So we're done annealing. Now it's going to turn on the jet and start threading. So you can already notice a lot slower than if I just have high speed on, right? Like I said before, when I'm in front of the machine, I don't want to wait this period of time. Usually I just turn on high speed AWT and thread the wire, right? But if I'm away from the machine, I want something more reliable. I don't want to miss my threads. I don't care too much about how long the thread takes. I would rather make the thread in the hole. Okay, so that's high accuracy AWT. If you can see, there's also a function right next to high accuracy AWT called jetless. With this function on, basically, when we go to thread, it's not going to use a water jet at all. So the idea here is if you have small holes, right, that you need to thread, at a certain diameter, right, the water jet is actually hindering you from threading. That water jet, if my water jet's bigger than the hole and it's splashing everywhere, it's going to have a hard time threading the wire, right? So if we're threading small holes, or if we want to thread in the kerf when the wire breaks, we can turn this function on and it will jetless thread. So just going to demonstrate that now. Thread the wire. Very similar to high accuracy, just as reliable, but there won't be a jet stream. On that note too, all of these functions, there are G codes that you can use to turn these functions on and off. So if I have a big hole in the same part and then a very small hole, I can use a G code to turn on high speed and then turn on jetless at that small hole. So now the wire's annealed. There's no jet stream coming out. Wire's coming down into the lower head there. Okay, threading's done. So high speed AWT and high accuracy AWT. Those are your two main buttons to control the threading modes on the machine. Think high accuracy, more reliable. A little bit slower, but more reliable. High speed, fast, less reliable. High accuracy, I'm away from the machine. High speed, I'm in front of the machine, right? So, a few more functions I want to talk about. One in particular is touch retry. So, what does this function do? Basically, after the threading cycle, if the wire's in contact with the workpiece at all, it's going to cut the wire and then try to thread again. When would you use this? So, say you have two holes that are really close together, right? There is a small chance that when I go to thread this hole, the wire seeps out into the second hole and threads itself. Using this, we can prevent that from happening, right? So as soon as the thread cycle is complete and the machine senses it's in contact, it will then cut the wire and try to thread again in the original hole it wanted to thread in. So that's touch retry. Non-contact search on M17. So this one's very useful. If I have a small hole, or say you hole pop a hole, right? And the hole is crooked, right? When I go to thread the wire and the wire's in contact, well, if the wire's in contact, the machine's not going to start cutting, right? So turning on non-contact search on M17, what this does is as soon as the machine reads that M17 code, which is power on, the wire is going to start searching, right? It's going to start searching in a big square formation, and then as soon as it's not in contact, it's going to stop, kick on the machining power, and then burn back to its original start location, right? So this is really, really useful if you have super small holes or your holes are crooked. You know, you don't have to go and re-drill the hole or reset up your part. You can just turn this function on, have the machine search for you, and then it'll burn back to its original start location and start cutting the program. Next function I want to talk about is M6 search after fail. So what this function does is if for whatever reason the wire can't thread a hole, say you have a big die plate, right? You have a ton of features, you have to thread 20 times, right? And when you get to the first location, the wire can't thread that hole for whatever reason, right? It'll try and try and try, it won't thread. With M6 search after fail on, what the machine will do is after a set period of time of it trying to thread, it will then dry run through that section, go to the next feature on the die plate and try to thread there and continue machining. The idea here is if I have a big die plate and it takes 20 hours to run and I'm running over the weekend, right? I don't want to just push the start button and have the machine stop and fail on the first hole. I would rather if it does fail, skip that section and then thread in the next thread location and continue cutting, right? So that's all the functions I wanted to explain on this page today. I hope you guys learned something. Now back to Brian.
Thanks, Anthony. Now, Anthony and myself are available for any questions that you may have about any of these features that we discussed or anything else pertaining to wire EDM.
Thank you very much, Anthony. I'm sitting here with Anthony. He's next to me. You might not be able to see him. There he is. So we're both here available to answer any questions that anyone might have about the presentation that you just saw. You can either enter them in the chat section there. If you look to the right-hand side of your screen, you can see there's a chat window, and there's also a Q&A window. Either one, you can type in any questions that you might have in there, and Anthony and myself will answer anything that you have. So I did have a couple of questions that came in earlier. So Anthony, this came in prior to someone watching the video, and they asked the question about during the jetless thread, they noticed that there was still water dripping off of the upper head. So why was there water if it's a jetless thread?
Yeah, so on our machines, we actually have two jets, one in the upper head section, we call it a transfer jet, and then one right below the guide. Now, when using jetless threading, we basically turn off the water pressure for the jet nozzle that's below the guide, but we still use the transfer jet to get the wire from, its cut location up into the upper guide. Now, the water you saw dripping was just from that transfer jet water getting blown out the back, helping the wire get through. And yeah, that's basically it. So
Okay. All right. All right. Very good. I also had another question that came to mind. During the presentation, we were talking about the M74 skip machining function, right? So where we have skip machining, we do M74, L1, L2, L3, marking all the locations. And then we also talked about M6 search after fail.
Mhm.
So those are used together, correct? Right. So we if we want to use the skip machining function and we program that, then we really need to have the M6 search after fail on,
Yes.
so that the machine doesn't stop if it misses a
Yes.
thread,
Yeah.
correct?
Yes, correct.
Okay.
Correct. Yeah.
All right. Yep. I just want to clarify that. That's what I thought. I just want to make sure that everyone understood that.
Yeah, that's a good question.
Okay.
Actually.
All right. Any questions? Anybody have any questions? Doesn't.
We were just too good at explaining
Yeah.
everything.
Yeah. Well, if anybody comes up with any questions that they have later, please contact me or Anthony, and we'll answer any questions that you have about the Hyper-i control. I want to thank everyone for taking some time today and watching our presentation. Thank you very much and have a great day.